Hey there, CS210 students. So this is Chapter 3, Part 2 recording. And in this discussion, we'll talk about the different types of loops that we have in C++. So for those of you who have a Java background, this will be very familiar to you because the syntax, the ideas are going to be 99% the same. For those of you that have had some Python experience, this will be somewhat similar. However, the way that we write the loops will be just just a little bit different than what you're used to in the Python. So first thing that they introduce here is in section 22, a while loop. So keep in mind, loops are to continuously repeat something. So a while loop works like this. So we go while, and then we have a tested condition. So this is the similar logic to an if statement. While this condition is true, excuse me, then we're going to perform statements inside the body of the loop. So whatever we are trying to do. So the thing that you have to make happen is you have to make this expression true at the start to make this execute. And then somewhere inside the body of this loop, this expression that gets tested has to be changed. So we would continue to loop and perform each of these statements as long as this expression is true. And if this expression is never made to be false, then you would have created a great infinite loop. And so your code is bad. You don't want to do that. So make sure that whatever you're testing here does get set to a false conclusion at the end of this loop body. So here's an example of a while loop. So we have a variable called current power. We have a user character that they're going to enter in, and the current power is 2. So they're going to do a little bit of arithmetic here. They prime user character with the character y. And the reason they do that is because that is the tested condition. So while user character is equal to y, and again, they primed it, so this is going to be true at the start. We're then going to see out what the current power is, so it would be 2, and then they're going to update current power. They're going to multiply it by 2, so we're going to print out powers of 2, 2, 4, 8, and so forth. And then they're going to ask the user right here for a user character. So this is the chance where we can exit out of this loop. And the great way to do this is to put this as the last statement of the body of the loop. So immediately then there, the next time through, it's going to check what is the value of user character. And if they type in something other than lowercase y, so the only way that this runs is if lowercase y has been entered in. So if it's not lowercase y, then we run the print the power, we multiply it by 2, and then again we ask for the current, we ask for the next character to be entered in. So here's another example where they're using user character as y, and again they've primed it so that it will be true at the beginning, and then they're going to convert some Fahrenheit to Celsius, I believe here. And then they're saying type Y to continue, other character to quit, and so then they get that character right here. To be honest, I'm not going to try to, I guess they're going to go by 5s here. Yeah, so the Celsius temperature is increasing by 5s. That's what they're doing there. So we can get the input before the loop. So I showed you earlier where they were priming the input so that it was going to be true, but we can also get the input before the loop. And we have an example right here. So we have a variable called usernum. We're going to get that input from the keyboard. And so whatever they've typed in, if it's greater than 0, then we're going to execute these two statements right here. Now, this is potentially bad because if the usernum is greater than 0, we're going to print. Oh, I see what they're doing here. So they are dividing by 10. Oh, I think that's still bad, right, people? So if I put in, say, so they put in 902. If I divide by 10, I would have 90. Oh, we're doing integer division. Yep, it'll work. So when we do 9 divided by 10, integer division, that's going to spit out a 0. I don't like code like this because this makes the person that's reading the code have to figure out what in the world are they trying to do here, what's the criteria. So maybe a good comment right here would be stating, this will run until 0 happens and we are using integer division. Again, another example where they're going to ask for a user input, get the user input from the keyboard, and then we can start the loop. And if this is true, then we will run the body of this loop. And if it's not true, then we wouldn't run the statements at all. I'm trying to find an example where they get the input and then they get it inside the body of the loop as well. Here we go. Perfect. So here, they're going to get some number from the user, and then you'll write this in your participation activity here. But you're going to check if the value is greater than or equal to 0. And so if that's the case, then we'll print out a statement. And then right here, we're going to get that value again. And then we'll start it all over again. We'll check if it's greater than or equal to 0. We'll print. And then we're going to be asking for the user input right here. So the next thing I want to look at is actually not in the textbook. So we're going to talk about the do while loop. So the while loop we just saw, here's the idea of a do while loop. The syntax goes do, and then this is the body of the loop. So whatever actions you want to repeat, and then we're going to have while our tested expression. And then that tested expression gets terminated with a semicolon here. So the idea of this is I don't have to duplicate code. So here they were prompting before the loop for a number from the user. And then they print, and then they get that value again. So could we turn this right here, could we turn this exact same code into a do while loop? So we would do something like this. We would do cout, enter a number, and then we're going to go user num, so cin user num. And we have to declare that variable before the loop. So we tell them enter a number, we then get the number. So then here's the body. And this would be a case where you do whatever you need to do with the input. And then we're going to do this. While user num is not equal to, let's say, -1. -1 indicates quit. So this will come through here, and if they put in -1, then we're going to exit the body of this loop. So this is a nice way that I can ask for the input one time. I don't have to ask it for it twice, here and also here. So I can ask for it once, and then I get it, I do some work, and then if it's not equal to whatever my exit value is, then we'll do it again. We'll say enter another number, we get it, and then we do something with it. And so probably I would even need to do something like this. If user num is not equal to -1, so then we would potentially do this printing statement of whatever work we want to do based on it not being a quit or terminate. So this would be an example using an integer. We could also use a string. So a lot of the applications that you're going to be writing throughout the semester, so maybe we get a user choice, so we don't have a number. So enter, no, we'll do an int. So user choice, and maybe choice 5 indicates quit. And so that would have been displayed previously. So maybe we have a print menu method here. And so we don't even have that enter a number. So we print the menu. We then get the menu choice. So we'll call that user choice. And then we'll handle the user choice here. So, if it's equal to 1, else if it's equal to 2, and so forth. And then maybe I do this. I have an else block. This is the non-work. Well, I'll just say this. This is the exit choice. And so then we see out application ends or whatever we're going to handle here. Okay. And then I would do something like this while user choice is not equal to exit choice, whatever it might be. And hopefully it's maybe defined up here as a const. So const int exit choice, and maybe it's equal to 10, whatever it is. And so if it's not equal to 10, we'll print the menu, get the user choice, handle the cases, and again, this would loop repeatedly. Okay, so that's the do while loop. Okay, so let's talk about the for loop. So back in zyBooks, again, if you've had a Java class, if you've had a Python class, you have used the for loop. The syntax for the for loop in C++ is very similar to that in Java because Java stole it from C++, but it starts out like this. It has some initial expression, so some value that gets created. This is the check, the tested condition. So what do we need to do? What has to be true in order to loop? And then something that updates this value right here. And then we have the body of the loop. And so this will go until the tested condition is false. So here's how it looks in C++. So we're going to have an int variable. We'll call it I. So we might be looping through an array, or typically we're going to be using I to represent the index. So in C++, you have to declare it before the for loop. So int I, it's declared, and then we go I equals 0. So we'll start it at 0. The tested condition is go until we get to less than 5. So that means we're going to go 0, 1, 2, 3, and 4. 5 is not less than itself, so we don't iterate. And then right here, we're going to increment I by 1. And we could have just done I plus plus right here. So we could have shortcutted it I plus plus. And then whatever we're doing in the loop body. Oh, by the way, a for loop can be written as a while loop or a do while loop. They can all be written interchangeably. So here they've got I, and we can set it equal to 0. So while it's less than 5, we do whatever we're going to do. And keep in mind, you have to update this value. If you do not update this value for this, then you would have an infinite loop. The advantage of this loop structure is that you do have an updated condition right here. This is where you update the tested condition. They have a comment, it'll be in here somewhere. Do not modify the value of I inside this loop body. That's going to create logic errors, and that is bad syntax. So only update the value of I right here. Okay, let's jump ahead to 3.27. So one thing that several of you pointed out in your intro discussions is that you struggle with nested loops. So just keep in mind that a loop that appears inside of the body of another loop, we just say they're nested. And you use multiple loops to handle different types of work. So here's an example where we want to create all possible 2-letter domain names. So the way that this runs is it goes from A, and then we have all the A values, and then next to it are all the A, B, C, D, so forth, all the way till Z. So we want all the A values and then match them with all the A through Z values. And then you can see then we start back over. So once we get through the end, we go B's, A, B, C, D, E, and so forth. And then eventually we'd be through the Z's, and then it would finish with W, X, Y, and Z. So the way that this code works right here is we're going to use a while loop, and we're putting together 2 letters. So the first letter, this is letter 1, this is letter 2. they're going to start letter 1 at A. So this is the outer loop. We're starting with A, and it's going to go A through Z here. The inner loop is then going to grab each letter at a time and add the .com to it. So here, letter 1 is A, and so while it's less than or equal to 0, we're then going to come here and we're going to grab letter A. That's this right here. That's this one. We're then going to print out letter 1, letter 2. So they're both A at the start. So A, and then we add .com. And then look right here, they're updating the tested condition. They're adding 1 to letter 2. So while it went from A, this time it's B. And we go A, B.com. Add 1 to it. So letter 1 is still A, and then we're going to have C and so forth. After this loop executes, once it gets past Z, so once we get to Z, we're then going to increment letter 1, and then it kicks over and this becomes a B. And then we start it all over again. While it's less than or equal to Z, we're going to go A, and then we're going to loop until we get that one to go to Z as well. So this is the outer loop. This is the inner loop right here. I might have said that backwards earlier, but this is the outer loop. This is the inner loop. Let me see if they have the example of, it wasn't in here. So just keep in mind, what's the purpose of each side of the loop? This is the outer one. This goes A through Z. This is the first letter. And then the inner one is going to grab the second letter as well as the .com portion. Okay, let's jump to 3.29. So the break and continue statements, again, in your intro Java Python classes, hopefully you got to a break statement. What these statements do inside the body of a loop is give you control on making the loop stop. So the way that a break statement works is when a loop is executing and when it gets to break, it stops that loop iteration completely and it will jump out of it and go see what's next. So take a look here. So we got a condition where 2 values are equal, and if that's the case, then we're going to break out of the loop. But we have 2 nested loops here. This is going to break out of the first loop that it sees. So right here, this is going to break out of this inner loop. And then it's going to jump into the taco loops here. So we must be eating tacos and figuring out empanadas based on we're going to get tacos probably after we get the empanadas taken care of. And then look, this tested condition says if the meal cost is equal to user money. So again, we don't have any more money. So we're going to break, and that is tied with not this for loop. Okay, if you keep your indentation straight, we are breaking out of this loop right here. While this example is the usage of a break, typically you're going to see a break statement used if you're going to be searching through, say, a list of something. And once you find it, you can break out and then not continue to the end. So that's a real good usage of the breakage. But this also works here. Scrolling down, the continue statement is the break's kind of cousin. And I say cousin because it will get you out of the loop, but what it does is it goes back to the loop condition, and then if that loop condition is still true, it still loops. So here, same loop structure, but now they got a little bit different condition. If this condition's met, then they're going to continue, which means we're going to jump back to the next iteration for this, and we didn't do any of this work right here. So this work right here is all totally based on this condition, and if we don't have this condition met, then we skip over and we say try it again. Typically you don't see it continue very much. I actually try to avoid it in my production code. Continues are kind of difficult to debug and keep track of where you are. Whereas a break statement, you know that you've just completely exited this loop, and then in this case, you've completely exited out of that loop right there. Okay, last thing to talk about. So as we're creating variables that are potentially inside other blocks, we talk about where they're defined and their access using the term scope. So scope means where was a variable declared and where is it accessible. And variables in C++ are declared in blocks, and blocks are defined with curly brackets. So if I come down here, I see this variable usernum. It's declared inside the curly brace for int main. So from here to this curly brace right here, everybody has access to the variable usernum. Same thing with new num. It's declared inside this curly. It's available anywhere inside this block. Same deal. It's accessible anywhere in here. But this variable val squared, it is only available from right here to here. So it's only available inside the body of this loop. So the idea is you want to make your variable scopes as minimized as possible. So if I only need value squared inside the body of this loop, I'm not going to declare it out of it. So as we can see in this loop, what we're doing is taking a value and we're just multiplying it by 2 here. And so user num is what they typed in. So they don't ever do anything with user num at all, do they? Nope. So maybe they probably should have used I right here, but that's okay. So keep in mind where things are defined are the only places they are accessible. A common error is to declare a variable inside a loop whose value should persist across iterations. So down here, the programmer expects the output to be these values, but they're just getting 0, 1, 2, 3, 4. And that's because this temp sum, they want to use I, well, it's getting rewritten every single time. Okay, so that is it for chapter 3, writing loops.